Okay, the start is actually closely linked to the actual problems we're going to be solving, in that we need to find the regions bounded by these inequalities, and the boundary lines for these are actually the equations of the lines. So if you change all the inequalities to being equals and graph them. The thing to remember when you're graphing these is always be careful where you're drawing the lines. Now I'm going to draw my lines quite lightly at the moment to try and make sure that we've got clear points. So x equals 2, that means that we're looking for all points where the x coordinate is a 2. And that's all these vertical lines down here. So x is actually where the line is, not the direction it goes in. So we have a line, I need to change the colour to really light. So we come down here. So x equals 2 is this line here. And I'm going to label it in a minute with black. Y equals 1, similarly, is a line that has the y coordinate, so something followed by a 1. So something followed by 1 is this horizontal line here. I'll just draw that in. And I'm drawing it very lightly because we want to use the inequalities in a moment. Okay. X plus y equals 5. There are a couple of techniques for doing these ones. I'm going to use just a quick summing, choose some coordinates that would make this work. So people often give me 1 and 4, 2 and 3, 3 and 2. I always start off with a 0. Computer scientist, just count from 0. So 0 plus something gives me 5, 0, 5, 5, 0. That immediately gives me 2 points to plot that I can draw my line through anyway. The other points would fill out the line for you. It goes diagonally through here. Now there is a mistake with this last line in that it's not going to cross over the others, but in itself it's not a problem. But what we need to think is the 2 is the intercept on the end. And that's the first thing to look at, is what's the intercept. Because that tells you where it goes. When x is 0, y equals 2. So we know it goes through this point, 0, 2. And we've got a gradient. Our gradient of m is 2. And that's the rise over the run. If there's no denominator, think, oh yes, there's a 1 on the bottom. So it rises 2 and goes across 1. So rise 2, across 1, rise 2, across 1. And if you follow the line, it goes through here, down, through the minus 1, 0, and keeps coming in this way. So these are the lines, and what I ought to do is label them. So I've just done y equals 2x plus 2. I've done y equals 1. I've done x plus y equals 5. And I've done x equals 2. So now we need to create the inequalities. And things to look at, first of all, did this the other way around in the lesson. But if I look at this first, this says not 2. So on a normal number line we'll do it's an empty line, and this time that means we need to have gaps in our line, so we do a dashed line. We've got a dashed line going down this way, for x is equal to 2. Then which side of this line do I want? And this is my tip for it. What I tend to do is I will use a pale orange. You look at the x and compare it to its sign, and it's on the large side. So we're getting bigger. So when I choose a point on the line, I want to make x bigger, which moves it to the right. So I want the region to the right. This diagram we're saying shade in, so I'm just going to put a little bit of shading on the side I want to shade. So little slash marks like that to indicate which side of the line I want to include. The other thing is to shade out, and you do it on the opposite side. You can do the same thing for the Y line. So let's have a look in black. And black. First of all, this is less than or equals 2, so it includes 1. Including 1 is a circle filled in, and we're going to do that as a solid line. Oh, let's go again. Let's have a look at the sign. Well, this time we're saying, so now we're saying Y is on the big side, so Y getting bigger. So if I put a dot on the Y line, I want Y to get bigger. Oh, I want above the line. Next two. You don't have to check both values, but I'm going to. First of all, it's equal, so include the line. So we want the line x plus y equals 5. Draw that in a solid line. And then have a look at the sign. We've got x is on the small side. Choose my point. Or y is on the small side. So y is coming down from it. Both of those agree. Same side of the line, so I want to shade on that side of the line. Now, so far, there's only one region now which is shaded all the way around. This one is completely open over here, but it might get included by this one. But it's not shaded on the orange. The orange bit doesn't shade that side. So let's have a look at the last one. And the last one is actually redundant because of the way it works. But we do not want to include the line. So in black, don't include the line. Also, what we try and say is it's on this y is on the small side, which means below, and x is on the wide side, bigger, and that means right. So on my line, I want below, and I want to the right. So everything along this point. Then if we shade in the region we want to shade in is where we're below this line, so that's all of these shapes. To the right of this line, that's only these shapes. Below that line, that's this area, and above that line, leaves us just that one region in the middle. So there's my region. And as a tip, I would label the region needed as well. And often you get asked to do it, but label the region with an R. That's the region they were talking about. Sort of follow-up questions that can happen is what points are there in integers that fit this? We're going to get slightly different ones when we come on to economic type things to find a maximum profit, maximum cost. And that's what this is used for. This is something called linear programming. And it's for, if you've got a number of different variables, you can control them, what's the best strategy to take? Say a machine, we've got a factory, you're going to get one which is making aeroplanes, I think, if I can remember where the question comes from. You have to find what's the best type of mixture of aeroplanes to make. But in this one, let's have a look. I'm going to take the brown pencil,
we need to find integer coordinates, so we need to be on the axis, the grid. These first three on the left, we can't include. We can't include them because they're all 2 equals. They say 2 is equal to. So we're not using 2, 1, 2, 2, or 2, 3. And that's because of the x must be greater than 2. If that said greater than or equal, these would be fine, but they're not. So the ones that are included are this point, and this point. So we've got 3, 1, 3, 2, and 4, 1. That's how to solve and satisfy those problems, given the actual coordinates. Okay.